Today what we're going to be looking at is how to graph the secant and cosecant. The first thing that we need to do in order to graph the secant is to remember that it's the reciprocal with the cosine function. The first thing that we're going to do is we're going to graph what the cosine function is. So here we go and graph it. When the cosine crosses the midline, so remember right here, and right here, what we're going to do is we're going to draw an asymptotes, vertical asymptotes for our secant function. So we draw them in. Okay, and we're going to draw them with dashed lines to recognize that they're asymptotes. Okay. Once we draw in the asymptotes, what we're going to do is we're going to draw in U-shapes along kind of the maximum points and the minimum points of our cosine function. So if we look at here, when the cosine is at its highest, when we look at our U-shape, it's going to have a minimum because it's going to be at its lowest point right here. Okay. And if we look at one that's upside down, like this one right here, it's going to have a maximum right here because that's going to be the highest point that's going to be on that U-shape. Okay. What we're going to be looking at now is, well, how do we get the vertical asymptotes of our cosine function? The way we get our vertical asymptotes of our cosine function is we're going to be looking at that first positive vertical asymptote. Okay, so our first positive asymptote in this case is pi over 2. Okay, and we're going to note that. So pi over 2. And then what we're going to do in order to find what the other ones are, because we have multiple of them, right? They keep going on. We want to find the distance between two of the two vertical asymptotes. In this case, we know that this is 3 pi over 2, this one right here. So we're going to find the distance. So 3 pi over 2 minus pi over 2 is 2 pi over 2. Which we can just simplify to be pi. We're going to need to remember that because what we're going to do is we're going to take whatever the number we found here, so the distance between the two vertical asymptotes, and we're going to multiply by n. Okay, so that's why we get pi over 2 plus n pi. And what this is just saying is that if we put in different numbers for n, let's say we put in 0, what we're going to find is that we just have pi over 2. That's that first one. If we put in 1 in for n, what we're going to do is we'll have pi over 2 plus 1 pi, and that's just 3 pi over 2. So it's going to give us that second asymptote that we have. And if we put in higher numbers for n, we're going to just keep getting the next vertical asymptotes that we have. Let's look at the domain. Since we know what our vertical asymptotes are, remember that our domain does not include the vertical asymptote, so it's just kind of the U-shapes that we need to account for. The easiest way to do that is to say, well, the graph is everything but the vertical asymptotes. Okay, so here's some notation. We can abbreviate for all real numbers by an upside down A, and then our real numbers is kind of an R with 2 lines on it. Okay, for all our real numbers x can't be equal to the vertical asymptotes, which we discussed down below. Okay, because our graph, remember, it just gets closer and closer to that vertical asymptote but never touches it. Let's look at the range of our secant function that we have. Remember that our range is our y values. Let's look at this one. So this one is all our y values greater or equal to 1. And if we look at kind of the U-shape down here, we're going to have all our y values greater than, our y values less than or equal to -1. We can write this in a different way. We can write it in interval notation. If you think about this one down here, our y is less than or equal to 1. What happens with the function is that all these y values are going to keep going down and down till -infinity. Okay? And then from -infinity, they get bigger and bigger and bigger, and then they finally hit -1. At -1, it turns down and goes back to the -infinity. So the way we can write these in interval notation is we're going to note that our negative infinity, it really doesn't have a number associated with it. So we're going to put a parenthesis around it. So this one goes from negative infinity all the way up to -1. And we're going to put a bracket on that -1 because it's included in that range because we said it's less than or equal to. So we do need kind of that -1 is in that interval. It's kind of the highest point on the graph. And if we look kind of at the other U-shape that's facing upward, we see that our lowest point is our 1, and then our graph is going to continue going up to positive infinity. So we're going to note that with, once again, our bracket, because 1 is included in it. And then once again, we said it's going to go to infinity. And that means that, well, we can't really quantify infinity, so we're going to put a bracket around it. If we look at the period of our function, we have to look at the period of the cosine function. In this case, since it's just regular cosine, we know that the period of cosine is 2 pi. And that's going to be the period of our secant function. If our cosine has a different period, that's going to also be the period of our secant function. What's special about the secant and function is that it has a y-intercept. It's going to be right here at 0, 1. Let's go ahead and graph our secant function. So we have y is equal to -3 secant of 2x. The first thing that we want to do is we need to graph our cosine function. So 3 cosine of 2x. We want to find what our period is. So remember, the cosine function is 2 pi, and then we want to divide it by 2. So what we find is our period is going to be pi. And that's going to be the same for our secant function. Okay. What we want to do first is we said we're going to graph this cosine function that we have. So we need to find what the marks on the x-axis are. So we're going to take pi and divide it by 4. So now what we know is all our tick marks on our x-axis are going to be pi over 4. So pi over 4, 0 of course, negative pi over 4. We'll do negative pi over 2. We'll do a few that way. Pi over 2, we have 3 pi over 4, and then pi, and then 5 pi over 4, and then we could say 6 pi over 4. We could reduce that, and then 7 pi over 4. Okay. So let's go ahead and graph our cosine function that we have. We know that at 0, cosine is going to be 1, so then this one's going to be -3 down here. Okay. 1/4, we know it's going to be 0. Pi over 2 is going to be 3. 1, 2, 3. At pi over 4, it's going to be 0. And then at pi, it's going to be -3 again. If we want, we could just continue graphing a few more just to get the shape of the cosine function and see the secant a little bit better. And I believe this one should be up here. Okay, so let's go ahead and graph our cosine function that we have. Okay. So we graph our cosine function, and now what we want to do is we want to draw in our asymptotes. Sorry. So we want to draw in our asymptotes. So let's use a different color to do those. I will draw it in red. Okay, so we need to know where it crosses the midline. So right here, right here, right here. And then we'll look at this one. It's going to cross right there. Okay, so here we have our vertical asymptotes. And let's write the equation for them. Okay, the equation for our vertical asymptote, we said is we're going to take the first positive asymptote, which is pi over 4. And remember, since this is our vertical asymptote, this is x is equal, right, because it's a vertical line. And then what we need to do is we need to have our n, And then what we want to do is we want to find the distance between the two vertical asymptotes. So pi over 4 and 3 pi over 4. So we're going to just subtract them. 3 pi over 4 minus pi over 4 is 2 pi over 4, which is just pi over 2. Okay, so we have pi over 4 plus n times pi over 2. So that's going to give us all our vertical asymptotes that we have. Okay, let's draw in our secant function. So remember, we're going to just put it in at the kind of the maximum and minimums of our cosine function. This one's going to be like this, and then we have this one down here. Okay, so now we have everything in. Our domain is going to be all x's such that x can't be equal to the asymptote that we just found. So we'll just put that in. Okay. And then our range, here we see that our y's these are less than -3, and then these are going to be greater than +3. So they go from remember it's a quantity from -infinity to -3. Make the bracket around 3, union 3 to +infinity. The same thing goes for graphing our secant. The first thing that we want to do is we want to graph the sine function. And everywhere where the sine crosses the midline, we need to draw in our vertical asymptotes, just like we have here. And when sine's a max, we're going to draw in our u. And when we have cosine being a minimum, we're going to draw in another u. Okay. The domain is a little bit different because the vertical asymptotes are different. Our vertical asymptotes are just at pi, and we notice it's pi distance between them. Okay. So we have just pi, and then we'll multiply it by n. This one has no intercepts, right, because we have another vertical asymptote here that's not shown. Okay. And then our period is 2 pi, just like our sine function, and our range, just like the other one, goes from -infinity all the way to -1, and then once it goes again from 1 all the way up to +infinity. Okay. Let's go ahead and graph our cosecant function. So 2 cosecant of x over 2 minus 1. I'm going to go ahead and graph it, and then you can check your work. So we need to graph 2 sine of x over 2 minus 1. So let's first find what the period is. We have our period, we know sine is 2 pi, and then we need to divide it by a half. So it's going to be 4 pi. Okay, so in this case, our period of our cosecant function is 4 pi. And in order to have our grid lines, what we want to do is we want to take 4 pi and divide it by 4. So each of our grid lines is going to be pi. Okay. I'm going to go ahead and graph the 2 sine of x over 2 minus 1, and then we'll come back together and graph the cosecant. Okay, so we graphed the sine function 2 sine x over 2 minus 1. So let's go ahead and graph the cosecant function. Let's put in our vertical asymptotes. Remember, it's where they cross the midline. So they're going to be right here. And then we have another one at 8 pi, and then there's going to be one at -2 pi. Okay, let's go ahead and find the asymptotes. The asymptotes we said is going to start at 0. And then we want to find the distance between them. So 0 and 2 pi. So 2 pi minus 0 is 2 pi times n. The domain is all real numbers x such that x is not equal to the asymptote. We can just simplify it to be 2 pi n. And then the range is all our from -infinity to -3, and then from 1 all the way up to infinity. And of course, I forgot to graph in our function. Okay. So here we have our cosecant function. That's 2 cosecant of x over 2 minus 1.